All right, ladies and gentlemen. So today we are going to be looking at an assignment called Intro to Trigonometry. And I'm going to import this into OneNote. So when you're looking at this later, you can hear what I'm doing. You can see what I'm doing rather than just hear it. But if you follow along on your piece of paper there, we're both going to be referring to the same thing. So trigonometry helps us find missing sides when we don't have enough information to use the Pythagorean theorem. So let's look at number one. We want to find the height of the triangle. But in order to do that in a normal situation, you would have to have two of the three sides. Then you could use a squared plus b squared equals c squared. But in this case, we don't have that. We just have a 70-degree angle. We have some long side here that has a word, starts with an H. And then X is the height of the triangle, okay? So next to that long side there that's got the 20 on it, I want you to label that hypotenuse. And that's spelled Hypotenuse. Hypotenuse. Now, in the top left corner of the triangle, you see that 70-degree angle? I want you to draw an eyeball, okay? Draw a little eyeball that is kind of peering down at an angle at the triangle, okay? This eyeball is your vantage point. This is from where you are looking, okay? And so we're looking from the perspective of that 70-degree angle. That X is the adjacent side, okay? So next to X, write the word adjacent, and that's ADJACENT. Adjacent, okay? Let me write it in cursive here. Adjacent. Okay, so we have the hypotenuse and we have the adjacent. So there are three sine functions. Three trigonometric functions. The first one is called sine, and that's spelled SINE. It's abbreviated SIN. Okay. And it is equal to the opposite side over the hypotenuse. Okay, so opposite over hypotenuse. Basically, you take the sine of an angle, some angle, and that's equal to the opposite side divided by the hypotenuse. Then you've got the cosine, and that's spelled COSINE, and it's abbreviated COS on your calculator. And that's equal to the adjacent side over the hypotenuse. And then you have one called the tangent function. That's TANGENT, abbreviated TAN. And that's equal to opposite over adjacent. So in situations where you're not given the hypotenuse at all, you use the tangent function. You might wonder, how do you remember all this? There's a little saying, a little acronym. All caps, write SOHCAHTON. SOHCAHTOA. And that stands for sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. So let's go back to number 1. Now we've got our learning in place. We're given 70 degrees. We want to find the adjacent side, and we're given the hypotenuse. So look at number 1 on your paper and write down cosine, or COS, open parentheses, 70 degrees equals adjacent over hypotenuse. In this case, x over 20. Now you're solving this equation for x, so you'll need to multiply both sides by 20. So now you have x is equal to 20 times the cosine of 70 degrees. Now in trigonometry, we work in 2 different measures. We work in degrees, and we also work in something called radians. We're not going to talk about radians right now, so we need to make sure that our calculator is set to degree form or degree mode. And so turn on your calculator and clear the memory. You do that by hitting second plus 7, 1, 2. Second plus 7, 1, 2. Once it's cleared, hit mode and go down to where it says radian and degree. And you'll see that it's defaulting into radian mode. So you have to go over and change it to degree mode. So go select degree and hit enter so that it's flashing on degree. Yes. Then hit second mode to quit. Now, we're going to just type in what we need to compute. 20 times the cosine of 70 degrees. So we're going to put 20 times the cosine of 70. And it's going to be already in degree mode. When you hit enter, you get 6.840402867. They want us to round that to the nearest tenths place. So that's going to be 6.8. So the answer to number 1 is D. Okay, and that's approximate. It's approximately equal to 6.8. Okay. D, 6.8. Zach, can you hand me those stack of papers there? Thank you. Appreciate it. Okay, now we're moving on to number 2. The very first thing we get to do is draw our eyeball. And that's going to be in the top right corner, peering down at an angle. Okay, kind of looking at this triangle from the top right corner. Okay, so they give you 48 degrees. And then if you look from the perspective of the eyeball at that X is sitting on the opposite side of the triangle. So you want to write next to the X, opposite. Some people abbreviate OPP. And then for the 11 is the hypotenuse. And the way you always know that is you look here at this right angle marker, and then you look across the triangle, and the side that is across from that right angle is always the hypotenuse. So this is going to be the hypotenuse. So I'm dealing with the opposite and the hypotenuse. If I go back and look at my trig functions, that's sine. Okay, so what you're going to write down in your work is you're going to say, look, the sine, S-I-N, open parentheses, you're really saying sine of 48 degrees is equal to the opposite over the hypotenuse, which is x over 11. And so to solve for x, you're just going to multiply both sides by 11. So that's 11 times the sine of 48. So x equals 11 times the sine of 48 degrees. Okay, so we've already put our calculator in degree mode. So we just go back and type 11 times, and then you hit the sine button, 48. Okay, hit enter. I'm getting 8.17. So that approximately 8.17, I have to round to the nearest tenths place. So I look at the 7, and I'm going to end up rounding that 1 up. So this is going to be approximately equal to 8.2, which would give me B. Okay, now we're moving on to number 3. On number 3, this triangle is turned at a strange angle. Number 3, the triangle is turned at a strange angle. So it sometimes helps to actually turn your paper so that the triangle looks easier for you. Yeah, kind of like on its side. If that helps you, that's fine. But basically, you want to draw the eyeball over by where it says 71. So top right, draw your eyeball. From the perspective of that eye, 18 is the opposite side. And from the perspective of the right angle, x is the hypotenuse. Okay. So next to x, we're going to write hypotenuse. I'll abbreviate HYP. And next to 18, I'm going to write opposite. I'll abbreviate OPP. So back to my trig functions. The cosine is equal to adjacent over hypotenuse. The tangent is opposite over adjacent, but the sine, okay, of some angle is equal to the opposite over the hypotenuse. So we're going to use sine here. Our angle is 71 degrees, so we say the sine of 71 degrees is equal to 18 over x. But this time we have to get x by itself, right? So this time we've got to do some clever work to get x to be by itself. So the first thing we're going to have to do, this is a two-step process, is we're going to have to multiply both sides by x. So now I have x times the sine of 71 degrees equals 18, because these x's cancel. And now to get x by itself, I actually have to divide both sides by the sine of 71 degrees. You treat it like it's a variable. So those cancel out. Now you have x equals 18 divided by the sine of 71 degrees. And so in here, we're going to go put in 18 divided by the sine of 71 degrees. And I'm getting 19.03. Okay, rounded to the nearest tenths place, that's going to be 19.0. C. Okay. Number 4, we draw our eyeball over by that 64. From the perspective of the eyeball, the x is the opposite side. And from the perspective of the right angle, the 10 is the hypotenuse. So I have the opposite and the hypotenuse. That means I'm going to be using the sine function. So we write down the sine of 64 degrees is equal to x over 10. We multiply both sides by 10. And so now I have x equals 10 times the sine of 64 degrees. So we go to the calculator and we type 10 times sine 64. We've got it in degree mode. So that's going to be 8.987. So x equals 8.987. I'm looking at that hundredths place. It's bigger than a 5 or greater than or equal to a 5. So I'm going to round up the 9. But that's going to turn into a 0, and it's going to round the 8 up to a 9. So this will become a 0, and this will become a 9. So it's going to be 9.0. Okay. B. Looking at number 5, we put our eyeball down in the bottom left of the triangle by the 31. Okay, this one's something new. From the perspective of the eyeball, the x is adjacent to the eyeball. Okay, so we're going to put A, D, J for x. And from the perspective of the right angle, 11 is the hypotenuse. So we have the adjacent and the hypotenuse. The cosine function, cosine of some angle, is equal to the adjacent side over the hypotenuse. So we're given 31 for our angle. So we write cos, C-O-S, of 31 degrees is equal to the adjacent side, which is x, over the hypotenuse, which is 11. So I'm going to multiply both sides by 11 to get x by itself. And x is equal to 11 times the cosine of 31 degrees. So we go type that in, 11 times cosine 31. And I'm getting 9.42. We look at the hundredths place, it's a 2. So this is going to be equal, rounded to the 10th place, to 9.4. B. Looking at number 6, we're given this top left angle. So I'll put my eyeball up there. Okay. From the perspective of the eyeball, the 12 is opposite the eyeball. So 12 gets OPP. And then from the perspective of the red right angle marker, the x is the hypotenuse. So the trigonometric function that deals with opposite and hypotenuse is the sine. So the sine of 74 degrees is equal to the opposite side, which is 12, over the hypotenuse, which is x. Now they want x, so we start by multiplying both sides by x. So I have x times sine of 74 degrees equals 12. And then I have to divide both sides by the sine of 74. Okay. Degrees. So x equals 12 divided by the sine of 74 degrees. And just for fun, because I know that not everybody has a TI graphing calculator at home, I want to show you something. The Google search engine actually has a built-in calculator that works. So what we need to do is compute 12 divided by the sine of 74 degrees. So we type in 12 // and then we put sine, SIN, open parentheses, 74 space degrees to tell that we want it in degrees, and it will compute it for you. I'm getting 12.48. If you're using your calculator, you should have gotten the same thing. So 12.48 will round up to the 10th place to 12.5. Okay, moving on to number 7. This looks a little visually confusing. They're actually giving you this top left angle of 75 degrees. So your eyeball is up there in the top left, looking down. From the perspective of the eyeball, 15 is the opposite side. From the perspective of the right angle, x is the hypotenuse. Okay? Opposite in hypotenuse is sine. So we're going to write out the sine of 75 degrees is equal to 15 over x. So we'll multiply both sides by x. Cancel, cancel. X times the sine of 75 degrees equals 15. So we have to divide both sides by the sine of 75 degrees. And we get x equals 15 divided by the sine of 75 degrees. I'm going to use Google again so you can see how this works. 15 divided by the sine, open parentheses, 75, and then I type out the word degrees. I'm getting 15.529. So 15.52. If I round to the nearest tenths place, I'm getting 15.5. A. Number 8. They're giving me this bottom left angle, so my eyeball goes down there. From the perspective of the eyeball, the 17 is adjacent, so A, DJ. From the perspective of the right angle, x is the hypotenuse. The trigonometric function that deals with adjacent and hypotenuse is the cosine. So we write cosine of 18 degrees equals the adjacent side of 17 divided by the hypotenuse, which is x. So to solve for x, I start by multiplying by x on both sides. And now I have x times the cosine of 18 degrees equals 17. Divide both sides by the cosine of 18 degrees. X equals 17 divided by the cosine of 18 degrees. So we just type that into Google like that, and I'm getting 17.87. which will round up to 17.9. Okay, B. Now we're moving on to the final two problems. Number 9, we're looking at the bottom right here. That's where my eyeball goes. Okay, so from the perspective of the eyeball, the 14 is opposite the eyeball. And from the perspective of the right angle, the x is the hypotenuse. So I'm dealing with the sine function here. Sine is opposite over hypotenuse. So the sine of 35 degrees is equal to 14 over x. Okay. So I'm going to multiply both sides by x. And I'll have x times the sine of 35 degrees equals 14. Then I'm going to divide both sides by the sine of 35 degrees. And x will equal 14 divided by the sine of 35 degrees. It's easy to type it into Google. I'm getting 24.40. So that'll just be 24.4. B. And finally, number 10, we've made it to the end. Put the eyeball in the top right at 56 degrees. So from the perspective of the 56, that x is the adjacent side, and the 16 from the perspective of the right angle is the hypotenuse. So the trigonometric function that deals with this is the cosine function. So we write COS, cosine of 56 degrees, is equal to adjacent over hypotenuse, x over 16. So to get x by itself, we just have to do one step here, multiply both sides by 16. And so x is going to equal 16 times the cosine of 56 degrees. So back to Google. 16 times cosine of 56 degrees. I'm getting 8.94. X equals 8.94. That's not a 5, so its x is just going to be 8.9. D. Okay. Thank you very much for your attention. Good job.